I want to put some LEDs in this prop. I've already tested the circuit. Now it's time to make some permanent connections. So to do this, we're going to need a soldering iron, some flux, and some solder. But before we get to the fun part, we need to cover some of the basics first. First and foremost, you're going to need a soldering iron. Now don't break the bank on an expensive model with all kinds of features you don't know how to use yet. I recommend practice a bit, figure out what it is you need, and then buy that model. I used a basic pen model for decades, and it worked well. Only recently, I upgraded to this modest soldering iron with temperature control. Now you need to use some solder, which comes in various types. You can use non-leaded versions, but I prefer the leaded version because it is easier to use, primarily because of its lower melting point. But the lead is toxic to breathe, so work in a well-ventilated area and use fans as necessary. I always use 60-40 solder, which means it has 60% tin, 40% of lead, and they even got in 1% of flux. Somehow I don't think that's mathing, but it's true. The flux is the last component. It is a chemical compound that removes oxide from the metal so the solder will bond to the metals. Flux will also help the solder flow through the joint. Before we begin our soldering, we first need to do some prep work called tinning, which is the process of applying a thin layer of solder to your soldering iron tip and electrical components. Tinning protects the soldering iron tip and components from oxidizing. Oxidizing is basically a layer on metals that makes soldering difficult to do. Tinning also aids in the transfer of heat, which is very important. Using a wet sponge or a wire tip cleaner helps this process. The advantage of the tip cleaner is it doesn't reduce the tip's temperature. Now let's move to soldering. First, I will apply the flux to the wire ends, add a bit of solder to the tip, and then place it against the wires to heat them up. Then apply solder from the other side of the wire because solder moves towards the heat. This makes for a hot joint, which is the strongest. However, if you apply all the solder via the soldering iron tip, or if you apply the solder directly to the solder iron tip, this is called a cold joint and can be weak and brittle over time. If the solder balls up or is overly bulky, these are some of the signs of a cold joint. To protect the wires from causing a short, you can use electrical tape, but I prefer to use heat shrink. You can use a lighter, a heat gun, or even the side of your soldering iron to shrink the tubing over the wires. For soldering to a board, the prep and the rules for soldering are the same. You can put the board on a wood table or use a special PCB holder like this. I inherited mine from my grandfather. A similar version can be found on Amazon, or you can just use some helping hands. Bending the components over allows you to flip the board over so you can make the solder connections. The joint should look conical, kind of like a Hershey's Kiss. Finally, make sure you clean up any flux residue with isopropyl alcohol, or it will corrode the components over time. Now, should you make a mistake and you need to remove a part, you can use solder wick as a medium to draw the solder away, which releases the part. You can also use what is known as a solder sucker. It is spring-loaded and it's able to suck away the heated solder when it gets to its melting point. To get the LEDs working on this prop, we need to connect some wires. I decided to connect the LEDs to an Arduino to make them come to life. So I need to solder the LED leads to some jumper wires. Using a bit of packing foam will diffuse the LEDs to give a more uniform glow. Sanding the backside of the button tiles will also help the light diffusion. Glue on the tiles, and now we have a great start to our Star Wars prop. If you want to see more content with soldering and electronics, click the links at the end of this video.